Hello everyone, welcome. We're in Metz Blida at HoliMaker. I'm Thibault Leroy, Marketing Manager for the French market at Formlabs, and in this second video, we get to the heart of this workshop, where we analyze a customer's needs and then embark on the conceptualization of a future product. There are two possible approaches to product development. In the first, your prospect or customer wants to optimize an existing product. You start from an established design with constraints to optimize or develop the new product on an existing basis. The second, your prospect or customer has a revolutionary idea and asks you to develop it from A to Z. For this workshop, we'll be working on the second option. To cover the industrial design issue, we've called on Herman Burr, mechanical engineer and industrial designer at OV Studio in Nancy, to help us with this project. Can you explain the working procedure? Once you've validated the idea, the specifications, how do you get organized?
So once we've validated the specifications, which stipulated an aesthetic and ergonomic object, we asked ourselves how much space the remote control would take up. To answer that question, I took some modeling clay, put it in my hand, and started modeling an element that could fit inside my hand correctly. This gave me dimensions and a shape that was generally ergonomic for the hand, allowing for a comfortable grip during extended use and minimizing strain on the fingers and wrist.
I then put this on paper to take the dimensions of the modeling clay and make the first aesthetic lines of the product, translating the organic form into a more refined and visually coherent design.
After that, I work on a tablet, which allows me to use the magic of Ctrl-Z and be able to reiterate shapes several times until I find the curve that seems most ideal. Another advantage of the tablet is that I can switch from a screen printout on the tablet to the computer easily. And as a result, I use the 2D views I have created to compile them on top, face and side, and then go from 2D to 3D. So I make a screenshot of the design, which I then export to Fusion 360 with the Canva function. This lets you create image planes that you freeze in the reference frame of the design. Then I make a plan X, Y, Z, which enables to superimpose the planes crosswise and then turn around and create sketches in several different planes until the sketches are joined to create a three-dimensional volume. In today's video, I'm going to show you how, using Fusion 360, I went from my initial 2D design to the final 3D model, which will enable us first of all to validate the ergonomics of the prototype we are going to print in 3D, and then to design the molds we will be using in a future video for this workshop. So, we're here on Fusion, where I've just brought my drawings on canvas. I'm only going to use the two views here, top and side, to make a tracing. We'll use the simplest possible shapes here, playing on the symmetry of the product, which is on the y-axis. I use functions such as lines and curves, and to enable those I draw closer to the product to effectively constrain the sketches. I connect the two symmetrical segments with curves that I constrain to ensure a good tangency, especially where the axis of symmetry passes through to ensure continuity of the curve. I'll repeat this operation on the other view, the side view, where I'll do the same thing with lines and curves, placing as few points as possible on the curves, and set the tangencies correctly, often horizontally and vertically. And now that we've seen the first two sketches, we'll move on to accelerating the various stages to model the entire remote control. I start with the cover, which is proportional to the top of the main body. I join the first sketches we saw together with a lofting to create the shape of the main body. I make only one half, which I join by symmetry. I then cut out this cover, as shown here, to create a lofting, which will give an inverted curvature effect. I take care of the junction between the wire and the circuit board, which is quite complex to make, following the existing interfaces, and here for the buttons I'm going to level them to recreate the rounded effect I'd designed. I'm using the cover holes to create the buttons by offsetting the faces. Next, I'll add all the screw wells in the body of the remote control, which I joined to the cover. You've also seen that I've enlarged the buttons to bring them back to the same level. And here I've created a space which will accommodate the junction to be molded onto the cable, which will be wedged into the body, between the cover and the body. Hence the need to create a dedicated space. Here, I add the reinforcements and ribs on the body part. I now connect around the button to make a single piece. Then, thanks to a small rod attached to the cover, I'll be able to connect the knob to the cover during assembly. You can now see that the inside of the remote control body is well ribbed and has a dedicated slot for the circuit board. I've also stripped the ribs and elements inside the body, and here I've renovated and added points that will be in contact with the circuit board to maintain its position. Now all the elements are assembled and modeled. It's mostly a question of minor alterations, such as the addition of undercuts or fillets to be added. I'll finish by adding standard elements such as screws to finalize the design.
Thank you, Herman, for preparing the files. Now I'll show you how to import them into Preform to create visual prototypes. The advantage of visual prototypes is that they allow us to validate the different geometries of the parts, which will then be injected. The first step is to import the files into Preform. This takes just a few seconds. Next, we select Draft Resin, which is a fast printing resin for prototyping, which will enable us to quickly obtain prototypes. To give the prototypes a finer finish and validate the geometries, we'll select a layer thickness of 0.1 mm. The next step is to determine the inclination of the parts. Preform already proposes dimensions, but you can also adapt them yourself. For all our parts, we generally choose automatic generation by Preform, and then we adapt them a little. Then for supports, we go straight to automatic generation. So after automatic generation, you can also add a few points where you think you may have weaknesses or changed points. For example, a point on a really technical geometry required to fit the parts together. For these visual prototypes, we also wanted to represent the electronic board to validate the interlocking of all the parts. As you can see, it only takes a few seconds. Preform gives us the right inclination and the right supports. We'll come and do this step on all the parts. What's interesting is that you can also see the printing time and the volume of resin that will be used, so you can plan your next prints. And now the file is ready for printing.
This was the first part, then this, the solid prototype, then the parts to be injected, and then the first injections.
With this, we come to the end of this second chapter. In the next video, Herman will explain how to move from assembling in 3-dimensional to modeling the 3-dimensional molds on Autodesk Fusion 360 in order to use them in HoliPress in a future video. If you have any questions, ask us in the comments. Otherwise, thanks and see you soon.